Hello everyone, my name is Athar Ramzan and I am a mentee in the Linux Foundation's LFX Mentorship program, working under the Open Mainframe Project's COBOL programming course. I had the privilege of being mentored by Sudharsana Srinivasan from IBM and Michael Bauer from Broadcom. The main goal of this project was to improve the COBOL programming course, which is a free open source course that teaches mainframe programming. I worked on developing 5 hands-on labs that give learners practical experience. These labs are designed to make concepts easier to understand, reinforce the theory through practice, and make mainframe programming more engaging and accessible. My technical goals were specified. I wanted to create labs that reproduce the most common COBOL errors that programmers face in real jobs. These These are called as events, which stands for abnormal end. Basically, when your program crashes, instead of just reading about these errors in the textbooks, students can now pause them safely, see what's happening, and practice fixing them. I developed 5 new hands-on labs and also enhanced the existing ones, focusing on debugging scenarios and common event errors. Each lab includes a COBOL program, JCL, and a step-by-step instructions on how to run and submit it. These aren't these aren't theoretical problems; they are real issues that happen in the production systems. Let me walk you through each lab one by one. This lab demonstrates the classic SOCB error, which occurs when a COBOL program attempts division by zero. Students run the program, see the event in JCL output, and then fix it by adding proper validation checks. This reinforces the importance of handling invalid inputs and writing defensive code. This lab this lab covers the SOC7 data exception error, which happens when a program tries to use non-numeric data in arithmetic. Students intentionally run the program with corrupted data, get a event, and then debug it and fix fix the input validation. This reinforces the importance of data integrity and also the concept of defensive coding practices. In this lab, students encounter the S322 event, which is a runtime timeout error, which occurs when a program runs too long, usually because of an infinite loop. They run a program with a faulty loop condition, get an S322 event, and then debug the loop to ensure proper termination. This lab emphasizes why current loop logic and safely checks are critical in COBOL development. This lab introduces the students to case-sensitive string comparison issues in COBOL. For example, if you see clients with capital C and clients with small c wouldn't match because COBOL treats them as different. Students first observe the unexpected results, then they learn how to normalize input using functions like uppercase and lowercase. It reinforces the importance of correctly handling user and business data in string comparison. In this lab 8.6, we take the client counting program a step further. The original version is hard coded to count only clients from one state. Here, students are asked to modify the program to count clients from a different state, such as New York. This involves changing the conditional filtering logic, updating the working story section where state information is defined, and adjusting the output formatting to correctly reflect the new state. The goal is to move students away from simply copy pasting the solution and instead encourage them to read the code, understand the flow, and make thoughtful changes. Hints are provided, and also the complete solution program is included for reference. So let's see the lab structure. Each lab follows a consistent structure. Students get complete source code and JCL. They run the program, watch it fail, and then step-by-step instructions guide them through analyzing the issue and fixing it. Each lab includes screenshots of expected errors, multiple solutions, approaches, and clear explanation of root causes and prevention strategies. This structure flow basically run, fail, analyze, fix, verify, and understand makes debugging a repeatable skill rather than just a one-time exercise. Let's see the impact and how these labs reinforce the learning. These labs are not just exercises, they are designed to make COBOL learning practical and impactful. On the technical side, students actually run into real world errors, debug them, and modify working programs. On the community side, these contributions modernize the COBOL education and support the Open Mainframe project by making its course more engaging and useful for new learners. Here are my actual contributions to the project. I have created multiple labs, as I said, including those for common events like S0C7, S0CB, and S322. I also enhanced Lab 8.6 to encourage deeper problem solving and also fixed documentation issues to improve the learning clarity. Five of these pull requests were merged into the official mainframe project repository, making these labs available for entire COBOL community. And one of the pull requests is still under review. This mentorship has been a huge learning experience for me. On the technical side, I gained hands-on knowledge of COBOL, JCL, mainframe tools like IBM Z Open Editor and Zubi Explorer. I also learned how to create effective educational content and work with errors. But equally important were the life skills, learning how to ask better questions, staying persistent when things can get tough, and communicating clearly and contribute meaningfully to the open source projects. To wrap up, I want to thank the Linux Foundation, the Open Mainframe Project, and especially my mentors Sudharsana and Michael for their constant support. I am really grateful for their support and they helped me throughout the whole journey. The labs I build are designed to help COBOL learners debug with confidence instead of fear. All my work is open source, so you can find it on GitHub. And also, I'm on LinkedIn if you would like to connect. If you have any questions about COBOL mainframe or the Linux Foundation mentorship program, I would be glad to help. Thank you for watching.